going to talk about Lightnin location system of upward lightning flashes. It's the first time we do some analysis of this type. We had a lot of analysis regarding cloud-to-ground flashes, but that's the first time we're going to check what Lightnin location says about upward flashes. So again, we are talking about the TLS 200, the Linet system, and the WeatherBug system, which is co-located with Linet. We are also checking what data from the some worldwide or long distance baseline says about these upward flashes. So the Vaisala GLV 360, the Woolen, this is a map of 2008, the StarNet, a map of 2009, and ATDNet, and we're gonna check what all these systems say about leader initiation, recoil leaders occurring during upward flashes, M components, and return state. So, what's a leader initiation? When it starts from the tower here and still not there up in the cloud, still propagating upwards. Sometimes we may see some detection during this phase, very few. We checked also if recoil leaders, these floating segments of luminosity that retrace positive leaders, if they are, for any chance, detected by any of the Lightnin location systems used in this analysis. This is a sequence of images, and here is a sequence of images when a recoil leader attaching that's part of the video Karina was trying to show you. You have an upward leader going up to this height and then spreading horizontally below cloud base, and then suddenly one of the branches get very faint. You lose track of it, and then recoil leader comes, retracing it and attach to the main channel, main trunk, and then goes down. That would be called a NEM component. When it does the same thing, but the previous channel is completely dark, no current at all, then we call this a return stroke. But there are some transitions from one to another. So sometimes this channel can be so faint, but it's still there, and then what do you see? Is this an M component, or is it a return stroke? Well, people usually talk the return strokes occur when there is no current at all, when there is channel cut off. So we call these guys return strokes, and those M components. When we see, even if it's very faint, we see the channel, we call it M component. So you must be careful with this distinction because it's subtle. All right, leader initiation. We got 2 detections out of 15 flashes, because during the Chauvin campaign, we got only, it's a bad word because it's quite a lot, 15 upward flashes in 3 months. Now, the total final count was 57 in a little more than 1 year. In U.S., we are working with Tom Warner and some people from South Dakota Mines and Technology. We got in these last 2 years, we got 5 upward flashes. So we got quite a lot, 57 in a little bit more than 1 year. So. Again, anyway, 2 detections out of 15 during the Chauvin campaign. No detection at all of these guys during any of these. And we have hundreds of these recoil leaders occurring. None were detected. Then 11 M components out of 38 M components along these 15 flashes. And then all return strokes were detected by one of the Lightnin location systems inspected. So this is the total count for each of the Lightnin location systems that were analyzed. We checked the TLS 200, only the LF part of it, not the cloud stuff. We checked the RIN.dot, intra-cloud and cloud-to-ground, Brazil.dot, intra-cloud and cloud-to-ground, LINET, intra-cloud and cloud-to-ground, but cloud-to-ground, no detection. Of course, the long, those the systems that have huge baselines between sensors, they couldn't detect any of these processes. Leader initiation, M components, recoil leaders, none detected out of hundreds observed with the video, and detected all 4 which observed with the high-speed video, and so on. So that's the final, I would say, the final result for the observed upward flashes during the sugar campaign. We're gonna do this. Amanda, which is doing her master thesis on this, will check all the 57 flashes, upward flashes now for the whole thing. So we are now just presenting the upward flashes observed during the sugar campaign. So the question about M components and return strokes, you can look at we checked the FAST field, and we see here what was classified was with as M components based solely on channel luminosity. So some M components, what we are calling M components, the previous luminosity in the channel was so faint that it really appears like very similar to a return stroke waveform. This is a pure, let's say, a pure return stroke, another pure return stroke, return stroke, return stroke. These are basically the 4 return strokes that occurred during the Chauvin campaign. All the rest were M components. So all 4 return strokes that were detected by TLS and some return strokes detected by RIN.dot and Brazil.dot occurred in one flash. Okay? And these are the peak current for each of the Lightnin location systems. Again, as Kleber said, Brazil.dot is peak currents are pretty lower than what the other systems measure. So we are calling these guys non-impulsive M components. So to distinguish from the impulsive M components. And the difference is the channel luminosity right before the recoil leader comes down. So as you see here, the recoil leader is coming through a channel is still there, but it's luminous, much more luminous than this one. I don't know. You probably see something here. So I had to call this M component because we still seeing some channel luminosity. So, but although this is called M component and this is called M component, you can see the channel here was much brighter than this one. So this was not detected, and this was detected because it's much more impulsive. Okay, and these are the field, E-field, fast E-field recordings for the M component and for the return stroke. This is the impulsive M component I just shown you, and this is a typical return stroke, kind of subsequent, similar to a subsequent natural return stroke. And if you want to know time here is 200 nanoseconds. So this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, about the same 0 to peak, about the same peak to 0. So they are both detected. Regarding detection, we got some pretty nice location accuracy. We compare the position of the reported location with the position of the tower. We know every flash occurring in the tower, and this for ring dot was below 500. That was a anomalous case, and I tried out. I still trying to figure out why sometimes it goes off scale. Like this is meters, so this is 29 kilometers. This is 500 and less. Brazil dot. Again, some very high values here, but in general below 1 kilometer. Brazil dot, huge value here, but less than 500. And TLS 200, some nice values. Some also big values. So this 0 here means below 10, because we don't have enough resolution to check if this is 2, 1, 2, or 3 meters. Anyway, it's below 10 meters on the top. So I believe these guys here are due to perhaps some process occurring along the channel, which is far away from the tower, and this part is detected, not what's going on over the tower. But I still have to check these. This is all recent analysis. And also LINET got detected when the leader was going up, when was detected. This was detected when the leader was still progressing. So in summary, the return strokes, the process mostly detecting upward flashes. However, their presence is scarce in upward flashes. We had only one flash out of 15 that contained what we call pure return stroke. Upward flash, that's the summary of my presentation. It's not trivial because you usually have this initial continuous current. You usually have M components which are not impulsive. So you have to wait for return strokes which are not very common. In these 15 flashes, only one had pure return strokes, or impulsive M component. And that's it. Thank you.
Thanks, Ken. Marcelo, so one here and then over there. Just 1 second.
Yeah. So did you see other pulses overlaid on the ICC current, the initial continuing current, other than what you're classifying as M components or return strokes? Were there other impulsive components, somewhat smaller in amplitude, or?
Yes, there are some impulsive. There are some. All these M components, I'm calling M components. They occur during the. If I call them M components because they are occurring on top of the initial continuous current.
Right, but other than the ones that you see clear signs of luminosity for, do you see other field impulsive components in the electric field measurements?
Oh yes.
So what I'm talking
about in the electric field.
Yeah, Marcelo, what I'm talking about is when you look at the initial continuing current for triggered lightning discharges, you will see lots of impulsive components, some of which may be M components, but you do see lots of.
Yeah. I have checked what these guys are.
Right.
This, and this, and this, and this.
Yep.
That's what you're talking about.
Right, and it'll be interesting to see also what the detection efficiency for these pulses are. Just a sort of a comment that we found for the triggered lightning discharges when ICC pulses have these impulsive components, the detection efficiency was found to be around 30% for a network like the NLDN. For these impulsive components, not the clear M components or the return strokes. And also another comment about the M components and return strokes. The only way you are going to make Ken happy is by actually measuring characterizing the fields for the M components and return strokes, trying to distinguish between them, and actually having current measurements in your tower to prove to him that the channel was actually not cut off. Oh, okay.
Yeah, the good news about this is that we are planning to have current measurement in this tower. So this tower at Jaraguá Peak is run by Globo and Bandeirantes TV stations here in São Paulo. And they allowed us to install some shunts and Rogowski coils and Pearson coils there. So they allowed us. So it's okay, I think. That's unless there is some other decision, but so far it's going well, and so we're gonna have soon some current measurements, and then we can check if that faint channel carries some current or not. Measurement.
Marcelo, here we have again this polarity, dramatic polarity asymmetry. On the negative end of the lightning tree, you don't have recoils, and you called attention to the huge number of recoils you get in the ground-based video. Do you have evidence, quantitative evidence, that the currents associated with the ground-based video, when you have the recoils, are less than the ones when you have these M components in the negative end? In other words,
yes,
can you compare video?
Yes. What usually happens is the upward flash starts with the upward leader, and only when it gets really faint, then it's when you start seeing recoil leaders. Then some of the recoil leaders may light up the channel again, and then they disappear. The recoil leaders disappear, and then you have only some long extension recoil leaders coming through previous channels that were already used. Was that an answer to your question?
Marcelo, have you seen if the location accuracy of RingDat and BrasilDat, they are all on the same side? You have a systematic error to the one side of the towers?
Yes. I didn't present here, but there's an offset.
Yeah, that's what I expect, because we have an offset location accuracy for the RingDat because we are not using the new algorithm for the sensors, although you are using the TLP, but we are not using the last 7000 algorithm, new algorithm for the initial stage. And the BrasilDat has also the systematic error for the topography. It's the same problem that you have in US. And Stan is working on that.
Yeah, in the previous presentation of Karina, where she showed the red spot right over the Jaraguá Peak, it's not right over. It's a little shifted.
It's due into the mountains. Yeah.
Is it due to the mountains?
Yeah. It's a propagation.
Yeah.
It's a difference in time propagation.